Hello! This will be a video on derivatives, how to take them. I'm going to invent some functions here, and then we're going to take derivatives of these functions. I believe practice makes perfect, so if you take the derivative of several functions, so hopefully you'll be able to catch the swing of things. I'll be introducing the product rule and the chain rule. I know you know that there exists a quotient rule. However, the quotient rule is not needed, as you'll see if you represent a function in the denominator as that function raised to a negative power, bringing it into the numerator. All you need to do is the product rule at that point. So let's do an example like that. Let's say a function f of x is equal to, let's say, x divided by the square root of 2x minus a 3. Okay, what is f prime of x? Well, some of you might be saying, well, this is a rational function. We need the quotient rule because these two functions are being divided by each other. I have to use the quotient rule. I can't use the product rule. Ah, but you can, because I can make any quotient into a product, like this. Now that I've made this quotient into a product, I can re-represent this radical as this expression inside the radical raised to the negative 1/2 power. And here's why. The 1/2 power means there's a square root over it. The negative part means it used to be in the denominator, and now we've brought it up into the numerator, as you can see here. Now, I will take, this is still f of x, all right? This is still f of x. Now we're going to take f prime of x. F prime of x. That is going to be equal to d dx of this first function, x, times our other function, 2x minus 3 to the negative 1/2, plus d dx of the function we did not differentiate in the first round, multiplied times the function that we did differentiate in the first round. Okay? So basically, in the product rule, this is the product rule. In the product rule, it says if you have a product of two functions here, x times the quantity 2x minus 3 raised to the negative 1/2 power, first you take the derivative of the first one, multiplied times the other one, add that to the derivative of the second one, multiplied times the first one, like this. Now we will do so. This is the product rule. It gave us this. To complete the calculation, we're going to need the chain rule. Over here, when we take the derivative of x, it's just 1. The chain rule is not necessary. But right here, when we take the d dx of the quantity 2x minus 3 raised to the negative 1/2 power, we will need the chain rule. Because you have to take the derivative of the outside with this negative 1/2 considered, and then the inside with just this 2x minus 3 considered. I'll show you what I mean by that. And I'll do that in a distinct color. And I'll show you when the chain rule gets involved. If I can find that pen here. I'm going to say chain rule. Okay? So, next, this calculation brings us to the derivative of x is just 1 times 2x minus 3 raised to the negative 1/2 power. Plus, now here comes the fun part, d dx of 2x minus 3 raised to the negative 1/2 power. You use the power rule, you bring that negative 1/2 down, and then you subtract 1 from the power. Then I get negative 3/2 because negative 1/2 minus 1 becomes negative 3/2. Take a look. Done. So that's why that occurs. And now we're not done with the derivative process, because here is where the chain rule gets involved. This is still, the product rule gave us this stuff. Now the chain rule gives me this. The chain rule gives me that this is now going to be d dx of the 2x minus 3. And then that will be multiplied times the x. because the x was still part of the product rule. So what is in blue is product rule, given to us by product rule. What is in black is given to us by the chain rule. The chain rule just says once you're done taking the derivative of the outside function, this thing, you also have to take into account the numerical value of the derivative of the inside function. So our calculation, if we work upwards, gives us this. This becomes 2x minus 3 raised to the negative 1/2 power minus 1/2 times 2x minus 3 raised to the negative 3/2 power times x times the chain rule piece, the piece that was given to us by the chain rule, times the derivative of 2x is 2, and the derivative of 3 is just 0 since it's a constant. So we get that 2 right there. Okay? So now the 2's cancel here. This 2 cancels out with that 1/2. And I can rewrite this over here. I'm going to erase, I'm going to put the chain rule over here. Black marker. From the chain rule, and with the blue marker, continue the calculation on. So bringing the calculation over here, I get this business is 1 over 2x minus 3 square rooted, because 2x minus 3 raised to the negative 1/2 power is really 1 over 2x minus 3 raised to the 1/2 power, and that implies it's the square root of all of that. So then that's minus this piece, which is the x stays on top, and on the bottom I get 2x minus 3 raised to the 3/2 power. X minus 3 raised to the 3/2 power means the square root of the quantity 2x minus 3 cubed. So this is equivalent to 1 over square root of 2x minus 3 minus x all over the square root of 2x minus 3 quantity cubed. And at this point you're done. And at this point you were done as well. Doesn't really matter unless it asks you to simplify or giving them a common denominator. Okay? So hopefully this example on how to take a derivative of these two functions was helpful in elucidating. Stay tuned for more videos on that, and I'll probably be doing a few more here in a second.